So the reason why we're going to slide number 17 is because there are some questions I want to solve with you based on the video that you had already watched on shapes of molecules, that 55-minute video. So the video ended on me doing some examples and also the overall molecules and shape. Just to recap, the more popular shapes, because they're the ones used mostly, is that you need to realize that you're working about bonds, you're working with lone pairs, and you got a shape and you got the angles. Now, for example, when you have two bonds and no lone pairs, the shape is linear, angles are 180. And you have three bonds and no lone pairs, your shape is trigonal, planar, all angles are 120. Then you have the four bonds and no lone pairs shape, tetrahedral. So you draw that like this. The drawing becomes equally important. And then the angles are 109.5. And then you also have variations of this with three bonds and one lone pair. So it's similar. Three bonds and one lone pair would be, now this is a lone pair. So about less than 109.5, about approximately 107, not always but approximately. Okay? And the last of these shapes that is also tied into the first one is two bonds and two lone pairs, and that was bent. Somebody asked me in the previous class, well, the bend shown in the notes, may one is sticking out of the board. And yes, when you have two bonds and one is coming out of the board, you can turn the molecule in a way that the two bonds are therefore in the same plane. So when you have two, then both can be in the same plane. Like these two, this can be turned in a way that they become in the same plane. So these are the shapes that we have to use. And most questions the shapes are based on this. You can learn this, rectify this, makes life easier once you've understood this. So let's go to slide number 17. And this is, by the way, found in slide number 13 of chapter number 5, the summary of all of this. But I'm now going to slide number 17. The first of the molecules is pH 3. Now, uske karne ke liye you need to know the out of valence electrons for each of them. Phosphorus ke valence are 5, hydrogen ka it's 1 each. So, as far as the bonding is concerned, this is the bonding diagram. 3 bonds or dot and crosses, and then one pair of electrons that are unbonded because 5 the. 1, 2, 3 तो यहाँ आ गए और यहाँ आपके 2 हो गए. And the way this is drawn is 3 bonds and 1 lone pair, therefore is how many? 3 bonds and 1 lone pair. And remember, when you're doing bonds, remember we're really just counting the sigma bonds. And we'll discuss it when we come across a double bond later. But 3 bonds and 1 lone pair is trigonal, pyramidal. And how would I draw this? The shape would be phosphorus, and on one side is hydrogen going down, and one in front of the board, and one behind the board. This one is out, and this one is in front, behind. And all the angles here are less than 109.5. कहीं कहीं 107 है, कहीं कहीं 105 है, 104 है. And don't be freaked out when you see bond angles of 104 even for trigonal pyramidal, because they have to be less than 109.5. Not always by the exact same amount. It's not always 2 degrees. Sometimes it's 3 or 4 also. Okay? So that's the first of the 3 questions, or many parts in this. The second one. Can I scroll? So if you've drawn this, the second question here was on sulfur dichloride, SCl2. Sulfur has 6 valence electrons, chlorine has 7. The sulfur shares only 2 and chlorine shares only 1. And we're only going to be concerned with the central elements electrons. So इसके 6 हैं तो 2 यहाँ bond हो गए हैं. So 4 नहीं bond and 4 becomes 2 lone pairs. And so this guy has 2 bonds and 2 lone pairs. That is bent. And the angles are about approximately 104 maybe. Kafi kam. Right? There you go. Yes. Then, इसके बाद, so this one is bent. Yeah, that's what we write that, bent. Then, can I scroll to the third one? Yeah. The third one is, part C is, yeah, dichloromethane, CH2Cl2. The bonding for this would be HCl, Cl, because they have 7 valence electrons, 1, and carbon has 4. So carbon is your central atom. The guy that makes the most bonds is generally your central atom. And when I look at carbon's electrons, 4 are bonded and 0 lone pair. Therefore, it will be tetrahedral. And any of the 4 can be hydrogens, and any 2 of the 4 can be chlorines. Up to you. But these 3 bonds point downwards. They are more than 90. Make sure you make them all point downwards. And any of these angles are 109.5. All right. Now, number D, part D. Can I scroll down? Now, part D में एक problem है. It's not cobalt. The formula is for carbon, oxygen, and 2 chlorines. When we do organic chemistry, this will be more obvious. The typo में नाम में typo आ गया. It's not cobalt. And carbon has 4 valence electrons, oxygen has 6, chlorine has 7. Which means carbon makes 4 bonds, oxygen needs 2, and chlorine needs only 1 each. So this is generally what COCl2 looks like, where carbon has made 2 bonds with oxygen, 1 bond with chlorine and 1 bond with the other chlorine. And so carbon के कितने electron थे? And they're already making how many bonds now? No, 3 bonds. A double bond is a double bond. And a good thing is that is for shapes, all you really are wondering is, a good way to remember this is that only count the number of sigma bonds. So here, you only care about, a double bond is 1 sigma and 1 pi, only care about the sigma. Sigma, sigma, sigma. So you have 3 sigma bonds. And when you have that, how many lone pairs do you have in this case? Carbon has 4 electrons, and चारों के चारों bonded हैं. So 0 lone pairs. So this would be your trigonal planar. Angles are 120. Yes? When you do stuff like, I don't have done this in the video, but this is where the whole sigma bond comes again. In a molecule like HCN, you got H, C, and triple bond N. So when you're focusing on the bond shape here, even though carbon has 4 electrons, it is making how many sigma bonds? 2. And how many lone pairs does it have? 0 lone pairs. So 2 sigma bonds and 0 lone pairs, therefore is 2 bonds and lone pairs, and that shape is linear. So that's what this is. No, sorry, what am I doing? Yeah, so yeah, the angles are, like this is the shape also, and the angles are 180. Now this one is a little tricky but a little fun, because that's what we're here to do. Something tricky and fun. If not, then what for? Now xenon is a noble gas. So outermost electrons कितने हैं इसके? 8 electron हैं. And fluorine के कितने हैं? 7. But fluorine needs to only share 1. So the way it must be bonding must be that there are 4 fluorines is bonding to. This is just the bonding. I'm not showing the shape right now. But outermost electrons कितने हैं इसके? So it makes 4 bonds, and outermost are 8 for xenon. So how many are unbonded? 4. That's how many pairs? 2. So I've got 2 lone pairs on 4 bonds. Total negative centers कितने हो गए? Electron centers 4 bonds हैं और 2 lone pairs हैं. That would be 6. And 6 की shape क्या होती है? Octahedral. So it's supposed to be 1, 2, 3, 4, 5, and then 6. My octahedrals always look ugly. Yeah. Anyways, now, so these are 6 of them. अब इनमें से 4 bond होने, 2 lone pair होने. And remember, all the angles are 90. And no matter how you look at it, ये ऊपर नीचे है. If I was stand in front of this will look like आगे पीछे, आगे पीछे. They're all the same 6 bonds. Like, no matter how you turn the molecule, they're identical. So any 2 of the 6 should be lone pairs. But lone pairs have the greatest repulsion, so they should be the furthest away. So whenever you put a lone pair, the other lone pair will be the opposite end of that. So if you put a lone pair here, then the other lone pair would have to be on this end. Put a lone pair here, this would be the lone pair. And whatever you do, the remaining becomes a square. Like for example, you might say, well, ये दोनों lone pair थे आपके. So बाकी 4 bond ये रहेगा आपके. आगे पीछे और ऊपर नीचे. That itself is a vertical plane of a square. The easiest way to recognize this as that कि नहीं भाई आप ऐसा करें, उनको वापस ले आएं जो 2 bond थे यहाँ. The easiest way to imagine this is कि जो आपका ऊपर नीचे वाले को lone pair कर दो. ये और ये. There are lone pairs, so their repulsion exists, but they are not visible. And बाकी 4 F's यहाँ होंगे. And when that's the shape, these 4 are perpendicular to each other in the middle plane. And when you connect these 4, they're like a square. So this shape is called square planar, just like trigonal planar. वो triangle in a plane है, this is square in a plane. This is a unique shape, doesn't happen much. This is when you have 4 bonds and 2 lone pairs. It'll result in square planar. So next guy we're going to talk about is, now let's go to slide number 19. So if you go to slide number 19, okay, some more examples there. I'm not doing all of them, I'm just going to focus on one particular one. CH3OH. And how do I make the, first I'll specifically only talk about this, but I also want to talk about the rest of the molecule also. So whenever you want to make the shape of something, you first draw the bonding diagram for this. So when I do that, I must remember this from O-level organic chemistry, where it must be H on 3 C's, bonding to O, bonding to H. Now carbon has 4 electrons in the outermost shell, all 4 here are bonded. Oxygen has 6 electrons, 2 are bonded, 4 are unbonded. That makes it how many lone pairs? 2. So this is my bonding diagram. Now if somebody were to ask you, bhai, O ke around kya bond angles honge? O has 2 bonds and 2 lone pairs. So what is the angles? 1, 0, about 4 approximately, right? But if I'd ask you, नहीं भाई ये कार्बन पे क्या है? इस कार्बन का क्या हाल है? इसके 4 bonds हैं. So must be 109.5. So to make the shape of this guy, this is how I draw the shape. So I want to make tetrahedral on the carbon. Now this is something that they won't ask you to do, but they will expect you to understand this. Is that this is what one way of drawing this would be. H, 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 O and O. And उस O के 2 lone pairs हैं. मैंने इस तरह क्यों बनाया है? इसमें ये कार्बन टेट्राहीड्रल बन गया और जब यहाँ नीचे O आया तो फिर इसका ये H यहाँ से बेंड हो गया. ये एंगल्स आपके हैं 104 अप्रॉक्सीमेटली और ये सारे एंगल्स हैं 109 अप्रॉक्सीमेटली. And you got, so this is the, but there's no name for the overall molecule now. The names only exist for a specific central atom. So you'll say the carbon here is tetrahedral, the oxygen here is bent. The overall molecule we cannot tell. ठीक है? But that's what this is. All right? Understand? Okay? Now, can I change this? So now, इससे मैंने एक बड़े मजे की बात करनी है, so that once you start looking at this, what you will realize is that इसमें कुछ are on a particular plane. Can you identify all the atoms on one particular plane? H, C, O, H. You see that, right? So, and it's not, doesn't have to be these 4. It could have been this H, this C, this O, this H also. We'll have to look at it differently. Let me explain to you what I mean by that. Is that when you look at tetrahedral, and was a good example of looking at tetrahedral. की बनाया मैंने हाँ यहाँ आते हैं वापस. Remember this question we did? CH2 Cl2 अभी. Slide 17, yeah. So this was you had these four. Now the way I have drawn it is, it is saying that carbon, hydrogen are in the plane of the board. But this chlorine, carbon and chlorine are also on a particular plane. Let me say this again. This carbon, this chlorine, this carbon are also on a particular plane. I hope my drawing can be imaginative, but if I could draw it, that plane would be in this like kind of slant, you see? It's that plane in this region, like that, coming out of the board. So not all planes are in 2D. Like, what is basically, if you want to understand dimensions, so somebody explained this really well on a video I was watching earlier, that what is two-dimensional versus one-dimensional? One-dimensional things are lines. And if this paper is 2D, then this plane of the paper is just an infinite number of those lines put together. And what is 3D? An infinite number of these planes. Like this is one plane horizontal, but so is this plane. But this is two 90-degree planes. There's an infinite number of planes that go in between these two also. But not just these two. There's also an infinite number of planes that go between these planes also. So this one would be this plane right here. Like something like this. So the point was that any two of the four bonds here can be in a particular plane. Even this one, this H and this Cl. And uske liye plane kya hoga? This particular one. Like the one coming out of the board like this. नहीं इन दोनों के भी हो सकता है. इनका plane यूं होगा. ये दोनों आ रहे हैं. So any two can be. And why I want to talk about that? Because I want to draw a molecule out right now. So to show you, because this will tie up to organic chemistry that we start in January. So, like for example, यहाँ हमने एक organic molecule ये देखा. I want to talk about another one that we will come across later, and that's called butane. But ये हमने O levels में किया हुआ, तो you'll have some idea about butane. What is butane? C4H10. For bonding structures, a good way to draw that would be CH2, CH like this. Oh my God, there's so many H's. Now, this is the bonding diagram of C4H10. In organic chemistry, we call it a discrete formula. Now, but the shape is not this. Each carbon here has 4 bonds, so each carbon here is tetrahedral. So if I were to make the molecule would actually physically look like this. The shape would be something like this. I choose to put the chlorines on the plane of the board. So the hydrogens are somewhere right here. In fact, I'll just make this even more straighter so that people can visualize that. Let's go यूं कर लेते हैं. So you got 4 here. So I've got this tetrahedral drawn this way, but then this will also tetrahedral. Now then, that means this carbon has to have 3 more bonds shown. Out of the 3 more bonds shown, one of them only can be in the same plane as this one. So it's up to us to decide which one we want to be on the same plane as this, because you can always shift them around. So what you realize is that I can draw it like this. And one way to imagine butane, one of the ways is like this. Okay, the 2 carbons start going on the same plane. And the 2 hydrogens are in front of the board and behind the board. They literally यूं निकल रहे हैं, बिल्कुल आगे पीछे जा रहे हैं. And then you got the hydrogens here. एक बाहर निकल रहा है, एक पीछे जा रहा है और एक नीचे जा रहा है. So you won't be asked to draw this. Do not worry. That's why no questions exist for you. But you should be able to imagine this and know that this is what's happening. That कि ये जो सारे हुए हैं, ये actually, this is the actual bonds. And every angle here is 109.5. And the way I have drawn it is that I made sure that all the 4 carbons are on the plane of the board. And the reason for that is because I want to highlight to you that every carbon has 4 tetrahedral bonds, but only 2 of them can be on the same plane. And here I've made sure that those 2 happen to be the ones that are bonded to carbons. But any 2 out of the 4 are on the same plane. And all these bond angles here are 109.5, 109, 109, all of them, these 2 also, sub B. And so what you realize is that the reason why we do this is because this gives us a very easy way of drawing butane. When you do organic chemistry, you'll realize the simplest form to draw butane is not to write C4H10, because C4H10 doesn't have to be only for butane. In O-level organic chemistry, you probably have done isomerism also. So C4H10 can have isomers also. So which isomer are we talking about? We're talking about butane. But how do I write butane simply? Like this. This is the simplest way of drawing butane. And you might say, huh? What? Huh? Let me say this again. It's literally like this. If this is butane, and why is that butane? Because it literally, all you do is outline the carbon-carbon chain. You see, down, up, down, zig, zag, zig. And each end is a carbon. All the bonds are single, so one line. And everything else in that node must be a hydrogen. That's why there's no need to draw it. It's assumed. Because when we start drawing it like this, we made up this way. So if we see it like this, we know everything else is hydrogen. So इस node के 2 bond बने हैं तो बाकी 2 क्या हैं? Hydrogen. इसके कितने बने हैं? 2 तो बाकी 2 क्या हैं? Hydrogen. And this is done later in organic chemistry. But इसका नाम है skeletal formula. But बाद में करेंगे, फिक्र ना करें. But I'm tying it to the fact that ये सारे angles क्या हैं? 109.5. And so the bond angles and shapes is much more effective when we're doing organic chemistry. It's very important for organic chemistry. It's very important to understand the reaction mechanism of organic chemistry. It's important to understand कि sigma and pi bond से क्या फर्क पड़ता है, bond angle से क्या फर्क पड़ता है. What you realize is tetrahedral structures are, see देखना, once you start realizing it, you realize that this kind of structure has a lot of things coming out and out in. It's all over it's 3-dimensional. But the 3 bond structures are trigonal planar structures. वो plane का फायदा क्या होता है? हर चीज़ एक plane में होती है. When everything is in one plane, what that means is on that plane there can be anything, but above and below the plane there is nothing. खाली है. And something that ties in shapes of molecules and pi bonds and sigma bonds, if you remember from class, the sigma and pi, is that pi generally happens to be above and below the sigma bond. So when things are trigonal planar and have pi bonds, that means the pi bonds are the only thing coming out of the planes. And in organic chemistry, those guys that have these pi bonds become much more reactive. क्यों? Because वो खुले होते हैं आसमान के नीचे. Anything can come and attack. When you have this kind of structure, you're like the atoms are pointing at you, coming in the way. Because at the atomic level, when things have to react, the atoms have to collide with each other. Especially with the central atoms. इसमें central atoms आपके पास क्या हैं? Carbon. Now, just to visualize this problem, and I have a few minutes, I want to discuss this with you guys. A couple of other questions also, but yeah. Just quickly, एक बड़ा मजे का isomer है, this fellow. CCH3, CH3, CH3. Now this guy is a कचरे की चीज़. क्यों? Because literally when you think about it, each carbon is making a tetrahedral structure. So you got literally 4 carbons like this. And each of this is making a tetrahedral structure. CH3 है ना ये भी. तो H ये रहा और H ये रहा. इसका भी H ये रहा, एक H out of the board like this होगा और एक into the board like that होगा. And this carbon का भी H और out of the board. It's so confusing now that you start realizing it. You know? And so when you have so many atoms coming out of you, all of this, getting for an atom to go and attack this guy is going to be very difficult. Because let's say अगर एक कोई reaction in organic chemistry में where this carbon has to be attacked. So understanding bonding and shapes, especially tetrahedral, which is all over the place, makes you realize that attacking this internal fellow right here, which is one, is hard to access. हाँ बाहर वाले कर सकते हैं, इस अंदर वाले को बड़ा मुश्किल हो जाएगा. So understanding that is important. That's why bonding and shapes is important to understand organic chemistry के mechanisms. Now, a few things are done. I want to one last question I want to do before I give you guys homework for this is that if you look at worksheet number 1, yeah. Okay, now worksheet number 1 se bhi, there's another question and sorry, can you scroll aage for a second? So there's a molecule on slide number 22 I want to draw first. I don't know if you've done this in the video. I didn't remember this. You didn't? Okay. So this is a large molecule in slide number 22. और उसमें क्या बोला गया, आपको कौन सा बॉन्ड एंगल चाहिए? OCN, this one. So now how do I find this bond angle out? Well, carbon has 4 electrons, and how many bonds is it making? It's making 4 bonds, but how many of them are sigma bonds? When it makes 4 bonds, that means it's used up all the electrons. But it only has 2 sigma bonds and 0. So 2 sigma bonds and 0 lone pairs should be what shape? Linear. And so this angle will be 180. On the other hand, if they had asked, yeah, इस bond का क्या angle है? This C double bond N single bond C. इसका angle क्या है? How many electrons does nitrogen have? The central atom is nitrogen. Has 5 electrons. How many bonds? 3 are bonded. So 1 is your lone pair. 2 bonded means 1 lone pair. 1 lone pair, and how many sigma bonds are there? Exactly. So 2 sigma bonds and 1 lone pair is a trigonal planar, but derived from trigonal planar. So it will be bent. This would be because because really what is this is 2 bonds, 2 sigma bonds and a lone pair. So that should be like 3 bonds, but a little less than 120. Because 3 bonds, if there were 3 sigma bonds, that would be 120. 2 with the lone pair will be like 3 bonds, but little less than 3 bonds. Page number 220. Question number 5. I'll just quickly draw these 3 out. There is CH3 plus, CH3 minus, and NO2 plus. So what is CH3 minus? How do you find the shape of this? Carbon has 4 electrons, but plus means one has lost 1 electron. So कितने बचे? And how many hydrogens are there? So 3 electrons and 3 are bonded, right? So how many lone pairs? So 3 bonds and 0 lone pairs with what shape? Trigonal planar. So it's CH3 like this. Then CH3 minus has 4 electrons, but minus means gained 1. That's 5 electrons and 3 are bonded. So 2 are unbonded. How many electron pairs is that? That's 1 lone pair. So 1 lone pair ye ho gaya, and 3 sigma bonds hain. So 3 sigma bonds and 1 lone pair is trigonal pyramidal, which is meaning 3 bonds and 1 lone pair. So 3 done. Then the last one. The NO The NO2 plus would look like this. Why? Because N has 5 electrons, lost one has 4 left. And O makes double bonds. So the 4 electrons are bonded this way. And there's a plus charge. So now how many bonds does N have? 2 sigma bonds. And 0 lone pair. So what would the shape be? Linear. So NO2 would literally be linear with bond angles of 180. Alright? Done? Okay. I'm going to change this. No, I'll just leave this here. I have homework for you guys. 5 MCQs, don't worry, not too much. Just 5 MCQs. Page 226, section A, questions 1, 2, 7, 21, 24. All right?